to start with, how many of you guys are on the software engineering side? Like, how many of you are software engineers here? Right, that's roughly half. Any like data engineers, ML engineers, or fancy other titles with data in the name? That's the other half. So, right, nice. So I guess most of you have heard about AI agents. If you paid attention in the last talk, you have. And also about MCP servers. Has anyone not heard about MCP servers? Looks like, yeah, one person. I will briefly explain what they are and sort of like the basics, and then we'll go into some more advanced features on them. And that's essentially the agenda for tonight. So there's 4 topics. The first one is a basic crash course on like what on earth is an MCP and how does, I guess, LinkedIn represent it, or like general social media. Then we'll look at some more advanced features that are less talked about, but are actually really useful. And then some common pitfalls that at least I've come across working at it myself, or just seeing people write blog posts on how stuff fails and being like, I can do better than that. And the 4th one is a real-world example. And that one ties a bit towards what we saw in the previous talk. It's writing LinkedIn posts. You see a theme here. Has anyone been to my talk at, what's it called? Mindstone AI meetup over in Microsoft, the Microsoft Nerd Center? One, I know you. Anyone else? No? Basically, what I did there is I showed a method on how you can actually use AI to write posts that don't suck. AKA, how do you manage context when generating posts? And some guy there commented, wouldn't it be fun if you turned that into like an actual program rather than like a manual process? And I was like, sure, let's try that. That's what the example is about. All right. A bit about me. I am Sebastian. I have a PhD in social robotics, which in a nutshell is using AI to teach robots a little bit about human social skills and psychology. And after my PhD, I went and worked as a product manager. I went through software engineering, data engineering, product management for a technical product. And I also do a bit of open source on the side. I maintain this beautiful library over here called Image.io. If you don't know what it is, you have seen the slides earlier from NumFOCUS on like what different libraries there are. There is one library called scikit-image. Scikit-image uses Image.io whenever you open an image. So if you've ever done that, you've used my library. Thank you very much. Right, so that is me. And I code a lot in my free time. That's basically how I ended up on this stage. I also was one of the organizers and founders of the PyData Stockholm chapter, which is why I knew PyData existed. And then I walked up and be like, can I give a talk? And fortunately, people said yes, so here we are. All right, the crash course on MCP. First of all, what does MCP stand for? It's the Model Context Protocol, which is model being the LLM that you're using. Context is the data that you use to stuff into your model so that you get the output that you hopefully want. And the protocol is a way to interact, or a contract on how to get that data. So it's basically a framework for how to structure the stuff you plug into your LLM. That's sort of a dumbed down version of it. But MCP is much shorter. Where does it actually help? I think the colors don't come through, doesn't matter. I think there are sort of 2 ways, if you think about like LLMs and completions, on how you can think of them. One is sort of the traditional, let's get a completion from an LLM path. And the other one is we want to build these fancy AI agents and we want to have tool calling and all that stuff. And those traces, aka sort of the stream of tokens that's being generated, looks slightly different in both setups, which is in both cases you have the prompt, the context, and the examples, which are set by you, the developer. The prompt being the system prompt. You are an expert software engineer, help me write a post, whatever. Help me sort of write a piece of code that generates a landing page, yada yada. Then you have the context, aka additional information about the agent, about the environment that the agent needs to know in order to fulfill the task. Examples for something called future prompting, aka this is an example input I might give you. Here is what I expect you to say. Here's another example input. Here's what I expect you to say in what format. And now the actual user request. This is the user coming and typing in stuff. And based on all this information, the LLM will hopefully do something useful. What it will do is, if you use a reasoning model, it will think on what is the correct answer, and then it will give you the response. That's the fairly standard, basic, well-understood format. The way MCPs help you is there are sort of three big components in MCP servers. The first one is resources, the second one is prompts, and the one that everybody talks about, tools. Resources help you structure this piece, aka the stuff that you write. Prompts help the user. They are basically templates for the user so they have to type less. And then we have tools which help you in this agentic trace. The agentic trace is a tiny little bit different. First of all, you usually don't have examples in the setup of your agentic trace. I'll not go into the reasons here, but if you want, we can talk about it later. But you also have a prompt, which is the system prompt, and its general instructions on what the system should do. You have the context, useful stuff that you know the agent will need. Then you have the request from the user. What's different, you reason again, but what's different is rather than immediately producing an output, you produce a tool call, which is the LLM gets a list of things that, how would you describe it, like additional functionality that you can do on behalf of the LLM if the LLM requests for you to do it. And then it will tell you at some point, oh, I want you to generate this file with this context, and then your program generates the file with the context. That's the execution bit, which is handled by the MCP server if you use MCP. Otherwise, you handle it manually. And then you generate a tool result, which is you passing into the agent or the LLM. This is the result of what I just did. And then this entire thing loops around. So then the LLM reasons again. There's maybe a new tool call, executed, tool result, and then you do the merry-go-round until the agent thinks it's done. And that's ultimately the difference between sort of normal LLMs and agents. Does that make sense? Wonderful.
What do you mean by manual execution? You mentioned that.
Like either you set up a server that could be like a third-party tool that runs that code for you. Like it knows, for example, like there's a GitHub MCP that knows when you say the MCP has a function called make a commit, and then you give it a commit message, and then GitHub will make that commit to that repository for you, or it's you calling the API by yourself. That's you manually orchestrating it versus some other third party orchestrates it for you. That's sort of the difference. It's really like, it's more language difference than actual practical implementation difference. Right. This took longer than I expected. Anyway, the most simple MCP server you can write is you import a library called FastMCP, which is, there's a fun story. FastMCP is a library that's inspired by FastAPI and tries to make you write MCP servers in Python very easily. The V1 of this library actually got merged into the official Python SDK from Anthropic. And now they have a V2, and the V2 is much better, but that one hasn't been merged in. So I would recommend you use FastMCP directly rather than using the official SDK. Because for now, that one's better. It has some nicer features. You declare an app, and then you do it basically very, how would you say, fast API style. Add app tool, defines a tool, you define the actual thing, what it does, and you're good to go. Now you've written an MCP server that has a tool. The tool definition itself has three parts that we'll come back to later. The first one is the name of the tool, which identifies the tool, and then the LLM will tell you, oh, please call the multiply add tool with A equals 2, B equals 2, C equals 3, right? That's the name, the input schema, which is a description of what parameters go into the tool, and then there is this description piece. And this description piece, I just put a very sort of short snippet of it there. This is actually important because this is the description that tells the LLM what the tool does and when to use it. And there's better and worse ways to write this definition. And usually if your agent doesn't do what you want it to do and it does random stuff, it's because this description is actually not good. So this is one of the main ways to tweak the tool and the agent to perform better. And we'll look at examples of how to do this in a good way later. On the client side, aka on the LLM side, this is the most minimal client you can possibly write, which doesn't have an LLM, because you can just call tools manually, which is, if I go 2 slides back very quick, this piece here of like the MCP server handling the tool call. This is the LLM says, call this tool. Your application takes over, forwards that to the MCP server. That's what this piece is, right? This is call the tool, whatever, with parameters, something, something, print the result, end. That's the smallest MCP client that I could come up with. And to prove that it runs, this will be very magical. You will not be able to guess the result of this. Let me see. Let me put this mic down. Yes, 1 second, I'll change the folders. And then let's zoom in. Right. This is the exact client you just saw. This is the exact server you just saw. And if I now do uv python run, uv run python, then it takes 2 seconds and it says the result is 7. Surprise. So it does work. Great. The most complex example you ever saw. All right. With that, I have a short section on how to write good tools. But if you followed me this far, you're now an expert and can go on LinkedIn and brag about how you understand MCP. Right. How do you write good tools? If we look at agents, this is a bit of a complicated slide, so I'll walk you. I should stand here, right, for the recording. I'll stand here for a bit. The basic idea for an agent is that you have a program that you want to execute, just like in normal programming. But the difference is that 2 things. First one is this first piece, the plan, like the steps you want your program to go through, are either generated by hand or generated by the LLM. The more complex your scenario, the more likely it's going to be that it's generated by the LLM, because it's hard to predict in advance what these instructions should be. That's one piece. The other piece is you have this list of tools on the other side. And for each step in the plan, the AI agent needs to figure out which tools do I need to call in which order to fulfill this particular step that I'm at and move on to the next step. And that's ultimately what writing agents is all about. Like, how do I, well, for you as the person designing the agent, how do I pick the right tools to expose to the agent? What is the minimal set of distinct tools that actually get the job done without introducing any fluff? And also, how do I make sure the agent can figure out which tools to use at which step to get the result I'm hoping for? That's ultimately what it comes down to. Which means tools are called for, fast forward a little bit, tools are called for 2 reasons. The first one is the agent needs to know something that it currently doesn't, because it only has access to its small little bubble called the context window. And it wants to go out into the whole wide world, the World Wide Web, query a database, look at a GitHub repository, cast through code base to find information that it needs. Then it usually calls a tool for that. Or it wants to progress from step n to step n+1, which then it ultimately comes down to 4 things that your tool must do well in order to work well. First, it must tell the LLM when and why to use it. Second, it needs to describe how to use the tool, like what are the correct parameters to pass in and how do I format those parameters. Third, what is the result for the LLM? It returns a result that is meaningful for the LLM, which is different from how you write normal APIs. Short example for that, if you have a standard REST API, usually you need some kind of authorization. If that fails and you provide wrong credentials, what we usually do is we provide the feedback unauthorized, period, end. That's not very useful for the LLM because it doesn't have context on what just went wrong. It will just go try random shit until it maybe figures it out. If you say, you need to access denied, you need to provide this and this token as part of the request in order to access this resource, now it gets a clue and it will actually start to put that in. And it's like little things like that that actually go a very long way for LLMs, but are not necessarily that useful for developers, so you might not think of them. And finally, it should also suggest good follow-up actions, because this is actually a cool little trick I found out a short while ago. LLMs are able to be, how do you say? You can prompt, what's the phrase for it? You can inject instructions in the return value of the tool call itself, and that will then guide the future actions of the LLM. Prompt injection, that's the name. It's sort of a bit of a security flaw of LLMs, but you can actually exploit it to do useful stuff. So while that's still possible, this is a good thing to do. Yes?
So at that point where it's like, it thinks the context is missing, is it possible that it can hallucinate context?
Sorry?
Is it possible that it can hallucinate context? And if so, like, are there any strategies?
It can happen. It depends on how you describe the tools that it can gather and how you set up your instructions. Like if you tell the agent, what would be a good example? I don't know if I can come up with one on the spot, but the gist is if there is a piece of context that's missing and there's a tool that says, if you're missing this piece of context, use this tool, the chance of it hallucinating is fairly low because it can just sort of follow the instructions at verbatim. Whereas if there is a piece of context that is missing and there's no way of making it up, for example, there's a good example. I tested an agent and I forgot to include the tools because I just didn't add the tools, but I tell them the instruction, use this tool in order to get the thing. It would call the tool and make up the result, right? So if there's no way to fulfill it, it will likely hallucinate and it will not tell you, but if there is a concrete solution for the LLM that you present, then usually it's fine. 95% of cases. Right. What does it mean? What do I mean when I say implementing tools, right? The first part is the name of the tool should be intent-oriented. So usually you start with a verb. In practice, I've noticed that this doesn't matter too much. As long as it's roughly in the right direction and there's nothing else that sounds similar, it works. But if you have many tools that are similar, like, I don't know, search Google, search Bing, search GitHub, then intent names are more important. So then it's like, I don't know, search for code might be a better name than search GitHub versus search Google. Of course, that is ultimately like very dependent on what's your actual application, but that's sort of the general gist. But names are not that crazy important. Parameters are more important. If you have a way to, how would you say this? Like if you have a way to get the value of the parameter that doesn't require the LLM to pass in the parameter, use that alternative method, even if it's slightly more complicated. It means that parameter will never be hallucinated and you'll never have problems with that one. It just makes things like your life easier. For tool descriptions, what I found works really well is first you have a section called use cases where you just list in which situation you want the agent to call the tool, basically dumb bullet point list. And then you have a list of instructions on how you want the agent to call the tool. That works surprisingly well. It's not how you would write documentation for developers, but for LLMs it works so nice. Yes?
So just out of curiosity, you have file name string. Would it be better to say path or the string?
So like this string piece here is not actually part of the file name. This is a type annotation.
Yeah, so,
right?
so there's a path type.
Yes, there's a path variable.
Would that help the LLM?
No, it would not because the actual type annotation needs to be JSON serializable. And the path is not JSON serializable. Yes.
Are you saying like in general, you could say that the MCP thing is it's ingested by the LLM as if it's a piece of text?
The MCP thing?
Yeah. Like
you mean like the tool description? Yes, absolutely.
It is literally ingested?
I'll show you later. Yes, it's literally just as text because all LLMs understand is text. Well, they now understand images and also audio to an extent, so some models do that, but the base is LLMs just understand text. So anything you feed in needs to be converted to some kind of text at a high level. There's nuance to that, of course, but that's the gist.
I had a question about the parameters.
Yes.
So if you have a long list of parameters, would it be better to encapsulate it in some kind of type? So let's say you had an image description. Would that help if you had a class definition that was of those components so that things were grouped?
My first throwback would be, do you really need a very long list of parameters? Because the longer the list of parameters, the higher the chance that one of those parameters will be hallucinated by the LLM and your tool call will not work. But if you really need a long list, that's a good question. I've had better luck with flat structures where I just list them all as flat individual parameters.
Okay.
But I haven't experimented very much with nested structures.
Gotcha.
So
Thank you.
Yes.
I'm just curious about the tool description. Are they generally pretty good, like LLMs, at like taking some description that you have and making it more friendly for LLMs? Like you feed them, or is it like half
LLMs have a. What you're asking is, in case you didn't hear the question, like, would it be? You tell me if I got this right. Like, would it be a good idea to ask an LLM to write the tool description for LLMs? Is that the question? Yeah, or like when you have a description, can an LLM improve it to make it better? It depends. Actually, if you tell it how you want the tool description to be written, aka you say include a section on use cases, include a section on instructions, yes, to an extent. It will not necessarily know your particular details on when you actually want this tool to be used. So if the LLM has that context, yes, it would be quite good. But if you write the actual tool, likely you don't happen to have context lying around with a full description of like, I want to use this tool XYZ cases. If you don't have that, then you're better off writing it manually because the LLM has no way of knowing. And then what you get is just a generic blurt of how general tool calling works according to the internet. All right. I think we're spending a lot of time back and forth with questions, which is very cool. I will have breaks in between sections for questions, and that's what I will enforce now, because otherwise I'll never make it through the presentation. All right. Next up on the return side, we've covered the input for tools, now the output for tools. If you have a return value, there's two pieces. First one is the internet suggests you write JSON files for this. Like the return value should be some JSON that gets serialized, sent over, plugged into your LLM as JSON. There's two things I don't like about that one. First one is JSON is actually really expensive. Like if you look at the tokenized version of JSON, it is actually consuming a lot of tokens, because every single curly bracket, every single colon is an individual new token, which adds up quite quickly. And the other one is Markdown just works better. And the reason is a lot of LLMs are trained in Markdown. They understand Markdown. Likely they also even output Markdown. And this is, the next part is sort of a hypothesis of mine. I suspect that a lot of the training data in the big AI companies actually is written in Markdown. So if the LLM is trained on a bunch of Markdown, why don't we feed it Markdown that it already understands? It's more efficient, it works, and it's nice. So even though conventional wisdom says do JSON, I think Markdown works better. And the other one is in the return value, if possible, and there's a clear next step afterwards, suggest that next step. So for example, like you've successfully created the file. If you want to know the content, use the read file tool. Now you have the recommendation on which tool to call next as the very bottom of your, or the very end of your stream of stuff that the LLM does. And that is weighted most highly, so most likely it will actually call the correct tool next. And that's a very nice way to nudge the agent to do the right thing. And the same for error values. Like, first of all, provide a descriptive error message. Don't just say, the provided file name uses an unsupported extension. For developers, that's fine. They usually have the documentation open on another screen anyway. They will just look over at the documentation and see what file types are supported. The LLM doesn't do that, so you need to give it the list directly. And then also, if you can suggest the next thing to do that. All right, that's it for a crash course on MCPs and general tool calling. So far, so good. Everyone's still with me? Oh, you both. Sorry?
If you go back one slide.
Yes.
I noticed your error handling
Yes.
is not only good for for an LLM, it's also good for humans.
Depends.
Because it's very prescriptive. It
Yes.
tells the human what you should do.
Yes, but if you're consistent with this and you push this to the extreme for humans, it becomes too long. There's too much text in too many places. And that's one thing. And the other one is, I don't know, it's maybe it's a programming style or a format choice on how you code, because I don't like just catching exceptions as they bubble up and replacing them with other exceptions with potentially more descriptive languages, because then your entire code base is just exception handling and you can't find heads and tails in your code anymore. So use it, it's nice, but use it sparingly. Yeah, the man in the back had a question before you, and then you can go. The question was, is this MCP independent?
Model. So will it work with any model, or is it only with a new model?
Yes.
To have an understanding of what
Yes.
MCP is?
All this stuff on like tool use is completely independent of the model, and it's completely independent of MCPs in general. Like you can use normal tool calling, you can apply these techniques. Nuance, some older models don't really support tool calling out of the box, so they might do random stuff. But newer models all slowly align towards the same interface, so this will work.
If you want to use more than one MCP, do you just do that by giving it a better description in each one, or do you tell the model somehow that there's more than one to choose from?
You don't need to give it a description of multiple MCPs. If you want to use multiple tools, yes, each tool gets its own description. But if you MCPs in this context, you can think of an MCP as a grouping of tools that are semantically meaningful to have together. You can have multiple MCPs in the same LLM, but you don't need to tell the model, because all the model sees is just a long list of tools.
So you can have more than one MCP?
You can have as many MCPs as you like. Many people do that. It's usually not a good idea. I'll show you later why.
So how will the model know which one to use? Will it know?
Your application figures that out. What the model says is call this tool. And then you have a name of the tool, and that name of the tool must be unique across all MCPs. So that there's a mapping from name of tool to which MCP with which tool. And then what people do, if you have multiple MCPs with tools of the same name, you prefix the name of the MCP in the low-level instructions that you pass to the model.
Tools inside the MCP, and that's how the model will know which one to use.
Yes. So the tools that the list of tools you pass over to the LLM needs to be a unique list of entries. So even if they come from multiple different MCP servers, the complete set needs to still be distinct. There can't be any duplicates, which you can solve with namespacing if you really have that problem.
Namespaces are a good idea.
Not having that many tools that you need namespaces is an even better one. All right, I'll move on. I think how am I doing with time? Did anyone track?
It's already so late, what does it matter?
51 minutes? 15. Ooh, then I need to speed up a little bit. That's okay. Advanced features of MCP. The gist of the MCP architecture is you actually have three things: MCP hosts, clients, and servers. Has anyone heard about hosts and clients and is confused about the difference? The difference is the MCP host is the application that you write. The MCP client is the SDK that actually talks to the MCP server. And the reason for this distinction is one MCP client talks to exactly one MCP server. And if you have multiple MCP servers, you will instantiate your host instantiates multiple clients that each have a connection to one server. And that's sounding like I'm splitting hairs right now, but in the spec it makes a difference because, how would you describe that? Because of things like elicitation and callback handling. We will see later there are client features like what, I'll skip that and forward that to later because I need to hurry up a bit. MCP servers can be local or remote. Local means they run in a separate process on your machine. Remote means they run on the internet and you talk to them through HTTP streaming. If you use a remote server, there's an entire can of worms on how you actually secure that, like how do you handle authentication, how do you handle scopes, how do you handle actually versioning, how do you handle not being ingested with random code that you don't want to run, because as I just showed you, the return value of an MCP server can ingest arbitrary stuff into your LLM. An entire can of worms, I'll skip it here. If you want to discuss it, find me afterwards. The unit of interaction. Now, on the low level, the interaction between the server and the client is JSON RPC, which really is just a JSON description of, here's the method I want you to call, here are the parameters, and then the result is, this was the result, and this is being ping-ponged back and forth. There's a third type of message called a notification. That one is a message without an ID. This is the short version. You are now experts in JSON RPC. Congratulations. Right. Next up, how do you establish a connection between the two? It's a standard three-way handshake where you have the host that spawns the client into existence with the correct configuration. The client then sends an initialized message to the server, says, hello, I exist, this is what I can do. The server responds with, hello, I also exist, this is what I can do. They negotiate a version of which MCP protocol version to use, details, and then that was my alarm because I'm supposed to start reading books now. Anyway, I'm very bad at stopping to actually read, and I usually just code anyway, so I now have an alarm to stop and actually do something else. Anyway, and then once you ping pong back and forth, the client says, okay, I got your message, now we both know what each other can do, and we can actually have a conversation. Then usually what happens afterwards is something called the tools list call, which is the MCP server has a bunch of tools. The client wants to know what tools exist, so the client asks the server, hey, what tools are actually registered? The server responds with a long list of tools that then get transformed into something that the LLM understands, and then the host takes over, and the host decides, do I want to pass that forward to the LLM or not? And this is one feature that I wish more people would use in, like, I don't know, Claude Code, Claude Desktop, Cursor. Whenever you add an MCP server, you can also select which tools within that MCP server should actually be included in your LLM. So, for example, the GitHub MCP server now has, I think, 102 tools. When I wrote this presentation, it had 99, and then they added a bunch. That's way too many tools, and likely you will not need like 80% of them. Just disable them. It saves you context, makes your LLM faster, makes things smoother, easier life. Yes. And then this is how the actual tool definition looks like. This one is how the MCP server sends it to you. It's, again, all JSON. Name of the tool, the description, we've covered that, the input schema, which is a JSON schema description of what parameters to pass in, an output schema, and annotations. Annotations are flags that exist in the MCP protocol that everybody ignores. So I will not talk about what they are, but they exist. And then you pass that forward to your LLM API, like OpenAI, Claude, whichever, and they then convert this JSON description into something that the LLM can understand, which is text. there's different approaches, different models, and they're all very secret about how they actually do it. But the rough, I don't know, I wouldn't say analogy. It's, in the early days, this was one way of doing it. Now it's probably slight tweaks of that. You convert it into JSON, right? You put the name of the tool as a title, you add the description, add a review, blah, blah, blah. You make a subsection for the input schema, subsection for the output schema, make a long list of that, throw that all into your LLM and see what happens. That's a gist. So that's to answer your question from earlier. Yes, it really gets converted to text and put in. Right. Once we have that, we do an actual tool call, which is the host kicking off a completion or an agent trace or whatever, and that passes over to the LLM. The LLM then runs through its steps, eventually says, hey, can you call this tool? That then creates a cool tool call that goes back to the host. The host then takes that request from the LLM, transforms it into something that the MCP can understand, gives that to the client talks to the server, then fancy client features, to do, aka next slide. The result of the tool gets returned, and that entire thing chain propagates backwards. Today, LLMs have a different format of formatting tool calls than MCP servers, which is mostly just renaming the parameters. I don't know why they can't agree on a naming, but life, I guess. All right. Client features. What are client features? This is where we get into the cool stuff that you don't typically talk about when you just have sort of entry-level, let's talk about MCP servers things, which is the client. Oh, we've talked about the MCP server having tools that it can run, and you can sort of request stuff from the server. The same can happen in reverse. The server can actually request stuff from the client because it's actually a bidirectional connection. And what it can request are elicitations, routes, and sampling. Elicitation is the MCP server wants to ask the user a question. For example, the LLM has just asked me to delete your database. Should I go ahead with that or not? Right? This is a quite useful thing to add into your tool because your tool is deterministic, so you are sure that it will ask you before it runs an SQL delete statement. Right? That's what it's there for. Or like if the tool realizes that a parameter was misspecified, rather than doing an entire loop through the LLM, you could just ask the user if there is a user. If you run like fully autonomous agents, then there is no user to ask, then elicitations are less useful. But you can also just ignore the MCP spec itself and have the application handle the elicitation. Up to you. Because ultimately how that's implemented is it's a callback, I'll show you later in code, that your application then handles, and the way it's expected to handle it is it needs to show it to the user, otherwise you just handle it yourself. Routes are sort of something to limit the blast radius. So the way you think of routes is, I have a project directory, I don't want my agent to ever modify any file that isn't in my project directory. So I'll list that project directory, hand that over to the server so that the server knows which files it's allowed to modify. That's particularly useful if your server runs locally and has access to the same file system. Also works with remote files or database schemas or whatever, but I've not seen that used yet. It's theoretically possible though. Finally, sampling. Sampling is a fun one. It's not really that, if you write both the LLM or the agent and the MCP server, it's not useful, but what it is rather than having your server go and make an LLM call by itself, if it's like a function that is partly agentic, does something smart, so rather than having it handle the entire interaction with a separate LLM, you can funnel the request through your client back to the LLM that your application is using to use that LLM for the completion, which is, I guess, mostly fun for product managers because it means that you don't pay for the tokens. It's the person using your MCP that pays. But yeah, that's, I guess, the main usage. It also might make your logic a bit simpler because then all the LLM communication happens in the client and all the tool handling happens on the server. Right, how do you do elicitations? In the code of the tool, it's very simple. You import this fancy context parameter, which is magic for the MCP that then injects context. And then you get this elicit method that you can call. And then you can ask, this will permanently delete all files in the workspace. Are you sure you want to proceed? And then on the client, what you do is, if you look at the bottom, you specify an elicitation handler. And what this elicitation handler does is it takes the message, shows it to the user, asks for a response. If the user types yes, then we go ahead. If the user types anything else, we don't. Very basic. You can put anything else in this function, right? Like you can make a nice UI, you can, I don't know, do check scopes, whatever. Right. Routes, similar thing. You import the context. You call list routes, which lists all the different trajectories, all the different resources that your server should have access to, and then you use them in some meaningful way. Note here that if you want to use the routes, you need to enforce it yourself. Like, your server can absolutely still call stuff outside if it has permissions to do it, if the operating system or something else doesn't restrict it. But this is a very strong hint and allows the client to configure it, and as long as, since you're writing deterministic code here, as long as you don't put any bugs in, it will actually still be respected. And then the way you put it in the client side is, again, you specify the routes when you create the client. Sampling, same story. The way you sample is you have the context and you call the sampling message, which looks fairly similar to modern APIs when you call large language models. Only exception is this thing doesn't support tool calls, which is kind of ironic that the sampling call in an MCP server, which is built for tools, can't handle tools. Oh well. And the other one is that you can specify model preferences. What model preferences are is it tells the client, ideally, take this request and send it to the first model in the list. If not, go down the list and send it to the model that you have access to. If you have access to none of them, anything will do. The way that looks in code is you have the sampling handler on the client side, specify the handler, off you go. All right. I will skip this example in the interest of time, but basically what this is actually just an implementation of all these different features in one example to show you. Right. Next up, we have resources. Has anyone of you heard about MCP resources before? I see one nod. No? It's one of those features that existed forever and nobody talks about it, once again. And what they are is basically a way for you to fetch, if you understand what a REST API is, you understand what MCP resources are. They're basically a way to fetch information from the remote server. Why would you want this if you can just have a REST API? Because you can co-locate useful information with the tools. For example, your tools might have a certain way of calling them that you figure out works well. So then you can have that snippet of text and you can embed that in, you can make that a resource, then your application can fetch that resource and use it while it builds the prompt for the model. I'll show you an example of that if I have time. Right. Then, yeah, so that's the gist of it. Like, if you have certain system prompts that you know work well, they're usually nice to co-locate with tools. If you have certain context that you know the agent is going to need, and you can fetch ahead of time, that's a good place, or if you have examples. Right. I will actually skip this slide because I think I'm running a bit short on time. But yeah, so this is just examples on like how do you actually build a system prompt and where would you then use the resources, which, okay, I'll spend 1 minute on it. Because this is I think the thing that if you understand this slide, you understand how to use resources, which is in this part over here, this is the part that you set up as the developer, right? Like this is the thing you pre-specify that you send into your LLM, which is the prompt, the context, and examples. And if we zoom in on the prompt that you specify, there's different frameworks on like how should you write a good system prompt, right? There's 5 parameters or 5 questions you need to ask, 3 questions, 4 questions, take your pick. It's a bit like diets, right? Like there's keto diets, there's if it fits your macros, there's Weight Watchers. What they all have in common is if you eat a certain number of calories, you will either gain weight or lose weight. It's the same with writing system prompts. Doesn't matter which framework you use, as long as you have all the key information there, it will work. This is the one that I happen to like, which is you specify the role of the model, you specify the environment in which it operates in, which is the scenario, like you're helping the user write a LinkedIn post, you're helping the user create a website, whatever. The style of the result that you want to have, like should it be plain text, should it be a certain JSON format, should it be written in, I don't know, Hindi, in English, in, Celtic. And then the instructions is a bullet point list of what other steps the model should actually go through. If you happen to have different sets of instructions, like you say, okay, if I ask you to give me a 1-3-1 summary of a thing, which is like, I have this problem that I'm trying to solve, this is the one, give me 3 different solutions to it, and then make 1 recommendation from those 3 solutions. I want you to do this. If I ask you to brainstorm with me, give me 3 different examples of the thing. If you have multiple sets of these, rather than putting all of them into one big context, you can make them different sets of instructions, make each of them a resource, and fetch the one you need on demand, which means there's less chance for the model to confuse what it's meant to do, because it only ever sees one of these instructions. Right. And finally, we have prompts. Prompts is the third piece that LLM servers, MCP servers are capable of. They are basically just templates that allow the user to be lazy. So you can do things like add brainstorm on your application. Your application then fetches, or the user says add brainstorm. Your application uses that as an indicator to go fetch a prompt called brainstorm, fetches the prompt, it's a piece of text, and it replaces add brainstorm with that text. That's all it's meant to be. Right, that was a very quick rundown. How am I doing with time? 5 minutes, good. That's not too bad actually. Questions? Yes.
So in the MCP you mentioned that there's sampling.
Yes.
What happens to the context of the client LLM? Is it like a fresh new context?
It's separate context.
It's a separate.
Yes. You specify the context as part of it. If I go back to that slide, like these messages, I think I'll show you later in the demo. I'll briefly show you the example too, where actually you see it, but it's a separate call to the LLM. So you have your context for your main client application, and then for the sampling, you spin up a new clean LLM, make the call, and then sort of throw that LLM away.
So this is a demo. You have 5 minutes. Like we have to sort of start wrapping up around.
Right. Right. In that case, I will skip the next section and go straight to the demo. Wonderful. Any other questions? No. Okay. Let's try the demo.
Let me just double check. We're still recording. Yep, we're still recording.
Wonderful. Demo time. I need to do the CD into magic. All right. What this is a combination of all the stuff that I just talked about, which is a MCP server that helps me write LinkedIn posts in a collaborative fashion. Or if you want to be fancy and use marketing speak, it's a multi-agent system that uses human in the loop to generate LinkedIn posts and automate your content strategy. There you go. Right. What it does is, I can run it and I'll show you. I should have a command. Wonderful. What you get is just sort of a user box. And then I can ask it normal questions, right? Just like a normal LLM. Right, so this is a generic LLM, and if we check the code for it, it actually is going to look like a standard LLM loop. Where do we have it? This is very zoomed in. This is the wrong example, that's why I don't find it. Right, so we initialize the client with some stuff that we don't really use yet. We have a loop that goes forever, which takes the user input. If there are certain special conditions met, which we just didn't set on, then we go through these. Otherwise, we skip all the way through to this response, which calls the LLM with the user-generated input and the conversation history, and the system prompt, which at the moment is nothing, which is why we get this generic, I'm ChatGPT, a language model, da 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 da. But if I now say something like, I can use a prompt, which exists here, I have this way. I've said that there's this option to replace the certain commands with prompts. What happens here is if I type @reminder, then there's this MCP prompt. If I scroll up a little bit here, we fetch the prompt name. We loop over all the prompts that the client has, and we add all of these into a list with the prompt name and the actual template, and then we replace it. So if I do that, this is actually quite hard to type with one hand. Then what this does, what this reminder does, I can show you on the server side. You can go away. Is it the wrong example? There we go. What this reminder prompt does is it reads the file called premise, which I've specified as a resource. It reads the file called ending, which are files that are defined in the these are files that are in the current working directory, which define that premise is, I've attended the PyData Boston meetup and presented about how MCPs work, and then it takes that context, takes that information and puts it in, which is why even though I just said reminder, it says, thanks, I've read the premise, the outline, and the pros. So I also have like an outline of a post, which is a bullet point list of stuff I want to talk about. I have the actual pros written in sort of, what is it called? There's a specific name for it when you have broetry. Yes, these like single sentences with spaces in between, the typical LinkedIn style, because I prompted it to write that way, right? I have all of this prepared, and now the LLM knows because I loaded it, so now I can say /context. And I think then I don't have time to dig into the details, but the gist of it is what these / commands do, because I set them up this way, is they set a certain system prompt, which I've prepared as a resource, read that in, pass that as a system prompt, and then there is also a certain set of tools. And this system prompt here, for example, resources, prompts, it has the instruction. It has these instructions. It says, your goal is to discover context that helps you write a better post. You have access to the add details tool, which is very simple. It just asks me a question, which you can see down here. It's actually the tool that gets called is add details. It runs an elicitation. The reason why I'm going through that loop rather than just prompting the user directly is because this actually preserves thinking tokens when, even though the user gets control back. Detail, we can check about that later. Yes, go ahead.
Hi, my name's Devin, and I'll be quick because I know I don't have much time.
Yeah.
Are there any real-world examples that you use MCPs to make like something of actual value that isn't AI slop? Because we all know that it's AI slop, and we all hate it. But like,
define AI slop. Like the thing with content is people don't necessarily hate AI, they hate bad content. Like if content sucks, even if it's written by a human, you will complain about that content as well if it's shit. If you, I don't know, there's this thing that my wife showed me yesterday, today. It's called what is it called? Strawberry Pants Kitten or something, like Strawberry Pants Cat or something. I see some people laughing. It's like an AI-generated, it's a channel that generates cat videos of a cat that wears like panties with a strawberry, and it's funny, and people love it. But sorry?
you wasted my time.
Oh, sorry.
Yeah, please respect the speaker.
All right.
Or don't.
No worries. All right. That notwithstanding, if you do run this, then you have, you see we do a function call, we have the LLM elicitation, and then I can answer the question, and that question then becomes part of the context, and then later I have something, for example, called the /outline command, which summarizes the outline, which summarizes everything into an outline and then writes it all out over here. And I think I'm running really low on time now, so I will just stop it here and maybe take 1 or 2 questions. One question, if it's quick.
Yeah, let's keep like quick questions. We should have to leave like this sort of context, I believe, by 9:30. So let's keep.
Okay.
Yeah.
So I have an idea of like I have trained. So I have this idea like I have a model that's been trained on the internet, and there's like a new version of Clang that's been released, right? And I want to tell the MCP, tell my model, like say it's Copilot, like hey, here's these new API docs. I want to use you to like search. How can I use MCP for that? There's like static content. Like we probably have to index it somehow, but like, is that possible to like inject that into the context, like and have it search?
I don't think just an MCP will be enough for that. Like MCP is ultimately just a way to bundle tools, resources, and prompts together into one thing, so it's easy for you to integrate with. But the actual sort of application, like in your scenario, how would I get the documentation that is online into something that the LLM can digest? That's an entire application that you can build completely independently of MCPs. And if you choose to use MCPs, you would do the exact same setup and then just put an MCP on the front.
So, like, if you could be very how would you do that?
Yeah, we can talk afterwards.
How many LLM calls did you make in that example? Is it just one, and we're
This will keep spinning. If I answer this one, I will not answer it for time. But if I make another one, then the control gets back to the LLM. It checks what was the answer, what else would I might want to know, ask another question, or maybe proceed with something else.
And is it the same context window in that LLM?
Exactly. It's the same context window. This just keeps on scrolling until the LLM is satisfied. Goes back to this piece here, right? Like this trace, like it goes around in the loop of like tool call, we execute it, it gets the result, it reasons again, makes a tool call until it feels it's done. And all of that is one long context. Hopefully it finishes before it runs out of context. Yes. Last question.
Yeah, great talk. I wish you had more time. Are your code examples available for us?
Not yet, but I can push them to Git.
Yeah, that'd be awesome.
Yeah.
Thank you so much. Thank you for